Okay, I figured out why this topic is so confusing. And you might even think it's confusing. You might think this is the worst topic in the world. You might think it's the most confusing topic in the world. I don't know, because I don't really try and judge it off your faces, and I don't say that obviously, but I think it's the most confusing topic because there's so many ways to do everything. I said I was going to post a bit of a summary. I'm thinking I don't want to throw that at you and throw a lesson at you, so I'm going to give you that next week, and there'll be a lesson next week where there won't be an exercise. It'll just be a bit of a summary video, and you can just watch that. So I'll post that next week. But for now, yesterday we looked at just finding the intercepts. Happy birthday, Charlotte. We just found the intercepts, and today we want to be able to find the vertex. Now, there's so many ways to do this, it's not funny, and I've listed them all there, and I'm going to work through these three. So the first one is actually, so these all back off like things that we've already done. So if I want to solve my equation, so if I wanted to graph this thing, I'd want the x-intercepts, and in order to do that, I can use a quadratic formula, or I could complete the square, or if I wanted to find the intercepts, I could just factorize, and this one's nicely factorized. So each of these methods for finding a vertex actually come from methods of finding the intercepts. So you're kind of not doubling your work, if that makes sense. Like you're not doing two separate things. Like if I complete the square, that allows me to find my intercepts and my vertex in this case. If I was to factorize, cool, I've already got my intercepts, and then I take the average of them, and now I have my vertex. Not like I'm doing anything new. I'm just kind of, I guess, going a little bit further with my calculations. So let's move these out of the way. Off you go. I hope they didn't exceed the screen. No, okay. So the first one, using the quadratic formula. So this might not be very obvious, but if I just draw in let's have a little bit of an aside over here. So this is an aside. I want you to think about any parabola. So I'm going to draw any parabola. Let's put it here, I don't know. Okay, now we know that this x-intercept and this x-intercept, no matter what they are, they're always going to be x equals minus b plus or minus square root of, and this one is going to be x equals plus b plus or minus, oh no, sorry, that part, minus, sorry, I mixed up the plus minus. That. Okay, so I want you to think about that in a little bit more depth. Like you've got the minus b minus the square root, and this is the, why did I write a plus? And this is the minus b plus blah, blah, blah. There's a reason for that, and see how it's like minus b and then it's minus something, and then minus b plus something. That means that minus b is actually in the middle. It's this square root thing. I'm gonna write it like this. This thing underneath the square root, I'm going to put a triangle there. All on 2a. All on 2a. That's a quadratic formula, yeah? So this thing here, that actually tells you how far away your intercepts are from your vertex. So you think you've got this minus b, and then there's a minus distance here. So think of like minus b, and then the square root over there. And then minus b plus the square root, so over there. I hope that makes some kind of sense. So in other words, this part here is actually the axis of symmetry. So that's actually an equation for the axis of symmetry. And then this thing, let me do it in a different color, green. This thing, that tells you how far away the intercepts are. From the vertex. I hope that made some kind of sense. So, in other words, this thing here, that's the very middle. So this x value here, the line in the middle, and then, should I draw another picture? I don't want to confuse it with another picture. So anyway, that is your minus b on 2a, and then that is plus the square root of b squared minus 4ac, and then this is minus the square root of b squared minus 4ac, if that makes sense. Maybe I'll redraw that picture afterwards. Anyway, so how does that help me? Well, if I want to find the axis of symmetry or the vertex, which is the same thing really, if I find like where the middle of the parabola is, so if I find the middle of it, I'm going to be able to find where the vertex is. So I can use the quadratic formula, or it's actually the formula for the axis of symmetry. So the axis, actually let's do it in red. Axis of symmetry, move that, is x equals minus b on 2a. That's now minus b, so remember that's a, b, c. Minus b is going to be plus 4 on 2 times 2, which is 4, so that's equal to 1. So that means that x equals 1 is my axis of symmetry. So let's chuck a line. I don't want it to be the same color. Let's go there. So that's my axis of symmetry there at 1. That means I know the parabola goes through that point. So now it's just a matter of determining, how high or low the parabola is and stuff like that. But what I can find is now my vertex. So since I've got the x coordinate where, so just looking at this one, I have the x coordinate for which, that point, I just want to know how high or low it is. So in other words, I want the y coordinate. So the y coordinate when x equals 1, trying not to confuse people. Okay, so y equals 2 times 1 squared minus 4 times 1 plus 3. That's 2 minus 4 plus 3. 2 minus 4 is minus 2 plus 3 is 1. That equals 1. So then y equals 1. So y equals 1 would be there. That means my vertex is here. Okay. I also know that because this is positive, that it's going to be concave up. So I can go like this, and I can go like this. And there's a couple of things you might notice from this graph. The first one's going to be it doesn't have any x-intercepts. So if I tried to solve that equation, then that wouldn't have given me anything, or the square root under here would have been wrong. Another thing, that means we can't factorize this. We could have completed the square, but that's as far as we need to go. So that's the first way of doing it. You can use a quadratic formula, which is literally just this part of it. You're going to care about that part of the quadratic formula to find the axis of symmetry. And then from that, you find the y coordinate. So that'll give you how high or low this vertex is. So that's how you find the vertex. That's one way. That should be the easiest way. There's not that much working out. And it's just remembering minus b on t. But you don't have to remember it because it's already, like if you have the quadratic formula memorized, then you should be fine. Okay, next one. Using completing the square. So let's complete the square on this thing. We've got y equals x squared plus, let's just write it 8x, and then I'll write a plus 5 over here. So I'm going to halve this, actually I'm going to write it like this. I'm going to add 8 on 2 squared, and I'm going to add minus 8 on 2 squared. So I halve it and square it and add it on. So then that's x squared plus 8x plus 4 squared plus 5 minus 16. Okay, so this factorizes nicely to x plus 4 squared. And then this is minus 11. Okay, so what that means is I'm going to draw x squared. Pretend this is x squared. Let me copy and paste it. Okay, so what you'll notice is this thing has been moved and it's gone left 4. And this has gone down 11. And you think about this, my vertex starts at 0, 0. If that then goes to the left 4 and then down 11, well, where's the vertex going to be? It's going to be at minus 4, minus 11, yeah? So that's literally it. So this is the vertex 0, 0. And then it goes over, so it goes minus 4. And then it goes down 11. So then that vertex is minus 4, 11. Whoops, on the minus 11. Okay, and this is y equals x. Right. That's y equals x. Okay, but again, you don't know x and y. You don't know what the intercepts are, so you'd have to. Oh well, I just solve this, so I move that over. So I have this, then I'd move that, and then I have 11. You know what I mean? So that's the second way. So you can complete the square and just think about how has it moved. And then the third way is if it's really easy to find your intercepts, which you're probably going to have to do anyway. But if I'd probably only do this if your intercepts were nice numbers. So maybe only if the ints are nice. So when we factorize this, so I'm going to find the y-intercept. Yeah, sorry, x-intercept. What is that? I'll make y equals 0. So then I've got 0 equals minus x squared minus 5x minus 6. So then I'll move everything over, so that's x squared, so that the x squared is positive, plus 5x plus 6 equals 0. That factorizes to x plus 2, x plus 3 equals 0. So that means x equals minus 2 and minus 3. So if I were to draw that, x is minus 3 minus 2. So then I know that it's positive because, oh sorry, actually I know it's a negative because that's a negative. So it's going to look like, wow. Okay, don't trust that. Just go with that. Okay, I know it's negative, I just don't know what this point is, but I know it's halfway between my two values here. If that's 2 and that's 3, that means my axis of symmetry is going to be the average of minus 2 and minus 3. So it's going to be, how do you do the average again? It's going to be minus 2 plus minus 3 on, get wobbly when I get to the bottom, on 2, and like I'm pretty sure it's pretty obvious what's in between these two, but it's minus 2.5. Okay, so that's my x coordinate. So my x coordinate's that. Then if I want my y coordinate, I'm running out of room very fast. If I want my y coordinate, I just shove x equals minus 2.5 into the original equation, or I can put it into this factorized. Oh no, I'd have to put it into here. So then I've got minus, oh it's minus 2.5 squared minus 5 times minus 2.5 plus 6. That's equal to, I don't think I have the answer to that because I made this question up, so now I'm going to have to minus 2.5 squared minus 5 outside of minus 2.5 plus 6 equals 49 on 4, which is 12.25. So that means this point is minus 2.5, 12.25. Okay. 13 minutes. I don't know if I want to redraw this question or not. Maybe I'll just go like this. That's the axis of symmetry. Maybe I'll redraw it over here in case you care. So I've got this and this. So you think of a parabola. Let's put it here this time. So this value here, that value there is x equals minus b on 2a, and then I hate that green. This distance here, well, so actually let's just go like this. This distance and this distance. I hate this picture already. So then this is plus the square root of b squared minus 4ac to get to there, and then it's minus the square root of b squared minus 4ac. Okay, I don't know why that picture was so hard to draw. Okay, so then these actual coordinates x equals minus b plus or minus the square root of. This is pretty neat, eh? Cool. Oh, that would actually be on 2a, wouldn't it? Because then I'm adding fractions. Oh well, I think it makes a little bit more sense to think about it like that. Okay. So, 3 ways of doing it. You can use a quadratic formula, or just part of it, minus b on 2a, or you can complete the square and move it, or you can find the intercepts and just find the average. So again, there's just so much stuff, but I'm going to summarize it next.